Hello everyone, so in this video we will be discussing the rules for differentiation. So we have here the list of rules that is applied or can be applied in deriving a function. So we have the constant rule, which is the derivation or the equivalent of the derivative of a constant value, which is 0. We also have the identity function rule, or the derivative of a variable, that is when you try to derive a variable x, that the equivalent derivative of that is 1. We also have the constant with a variable. We have the constant c and the variable u, so you just have to copy the c and then derive the u, multiply that to the constant. And then we also have the sum rule, or the difference rule as well. This is also applied. We have the derivative of u plus the derivative of v with respect to x. And then for the product rule, we have the derivative of u times v. So in this case, you have to have, or you have to copy the u. You have to copy the u first, derive the v with respect to x, plus copy the v, derive the u with respect to x, and then multiply that to our v. And for the quotient rule, we have u over v, and we have to copy the v, or the denominator, multiplied by the derivative of the numerator, or the u, with respect to x, minus copying the u, or the numerator, multiplied by the derivative of the denominator, which is the v, with respect to x, all over v squared. That is for the quotient rule. Now for the power rule, we have u raised to n, and n is any number, or any constant number for the exponent. So you have to put the constant or the exponent before the variable u, and then subtract 1 from the exponent that we previously have. So we have n times u raised to n minus 1 multiplied by the derivative of our u with respect to x. For the radical rule, we also have the derivative of the variable u, square root of u, that is equivalent to the derivative of the u, or the inner equation, all over 2, and then copying the square root of u. And we also have 1 minus u raised to n. So you have 1 over u raised to n. You have to negate the sign and put that in the numerator. Sign of the exponent and put that in the numerator. And then copy the function u. And then for the exponent in the denominator, you have to add 1. Multiply that with the derivative of our u. So basically, this is the overview of the rules of the derivative, or the differentiation. So now let's try to apply these rules that we have in solving some examples. So we have here the first example: differentiate the following. Y is equivalent to x to the fourth plus 2x cubed minus 12x plus 7. So in this case, in order for us to derive this one, we need to follow some rules. As you can see, there is a power. So power rule will be applied here, as well as the sum rule and the difference rule. So those are the rules that will be applied in this example. So first, let's determine the derivative of our y. In writing the derivative of the y, you have to put that, or you have to write y prime, or y raised to 1. That is also understood as dy, or derivative of y with respect to x. So that is just equal. Now again, in power rule, you have to put the exponent beside or before the variable. So we have 4, and then x, and then for the exponent, we have to subtract 1. So we have 4 minus 1. And then the derivative of our x, which is 1. So we have 1 here. And we have to do it again with the second term. So we have 2, and then put the exponent beside the constant and the variable x, 3 minus 1. And the derivative of our x, which is 1, minus 12, and the derivative of x is 1. So since the x has no exponent, then the derivative of that is 1. And plus 7, so the derivative of a constant is automatic 0. So that is the derivative. Now, we just have to simplify this and see our final answer. So we have 4 times 1, that is still 4. X raised to 4 minus 1 is 3. So 4x cubed plus 2 times 3, that is 6. X raised to 3 minus 1, so that is 2. Times 1 for the 6, that is just still 6. So minus 12 times 1, that is 12. So basically, this is now our final answer. Next example we have here, y is equal to 3x minus 1 minus 4x minus 2. So for this one, this equation is also equivalent to 3 over x minus 4 over x squared, right? Because the exponent is negative, meaning to say you can put that in the denominator. But we'll just solve this one using this format, a line format. So we have y prime is equivalent to 3 times negative 1, x raised to negative 1 minus 1, minus 4 times negative 2, x raised to negative 2 minus 1. So simplifying this, we have negative 3 x raised to negative 2 plus, since this is negative times negative 2, so that is plus 8 x raised to negative 3. And again, our final answer can be this one, or we can also write this one in a like this form. So we can write that as negative 3 over x squared plus 8 over x cubed. And since this is negative, we'll just have to put that here. So we'll have 8 over x cubed minus 3 over x squared. So we can have also this one as our final answer, or this one. Basically, they are just the same. So that's it for this example. Next one, we have this example. As you can see, this is a multiplication of a polynomial. So here we'll try to apply the product rule of the differentiation. So basically, you can just also try to distribute this one and then perform the derivative of the sum or difference. You can do that. But also, you can also try to take this into take this one as our u and this as our v. So that being said, we have in deriving a product, again we have the u dv plus v du, right? So if you can remember that, that is derivative u derivative of v with respect to x, and v derivative of u with respect to x. So this is how we derive a product. So from here, this is our u. So just copy the u, which is v squared plus 3, and then derive our v, multiply it to our u. So the derivative of our v is 2v minus 1, right? And then we have the v, copy the v, that's v squared minus v plus 1, and then derive our u, which is this one. So the derivative of u is 2v, and plus 3, that is the derivative of the constant 3 is 0. So let's just simplify this one. So let's distribute this. We have 2v cubed minus v squared. So we have v squared plus 6v minus 3. We have 2v cubed minus 2v squared plus 2v. Now simplifying our result, we have 2v cubed plus 2v cubed, so we have 4v cubed. Negative 1v squared minus 2v squared, so we have negative 3v squared. 6v plus 2v, that is 8v, minus this one, our 3. So this is now our final answer. So another example we have here, y is equivalent to x plus 1 all over x minus 1. So taking our numerator as our u and taking our denominator as our v. So now we have, in deriving quotient, we need to use the quotient rule. So in quotient rule, we have the v du minus u dv all over v squared, right? So copy the u, copy the v. So we have x minus 1. Derive the u, which is the derivative of u is just 1, minus, this is 1 because, again, the derivative of x is 1. The derivative of 1 is 0. So 1 plus 0 is just 1. Now, copying the u, which is x plus 1. And then deriving our v, so that is still 1. And then divide that by the v squared. So our v is x minus 1, so squared of that. Now, simplifying our equation, we have x minus 1 minus x minus 1 all over x minus 1 squared. Now, x minus x, this is just equivalent to 0. So we have negative 2 all over x minus 1 squared. So this is now our final answer. Next example, we have y is equal to 5 minus 6x. So this is the derivative of a radical form. So if you can remember, if you have a radical of square root of u, the derivative of that is du over dx all over 2 square root of u. So now, we'll take our u as equivalent to 5 minus 6x because this is inside the square root, so that is our u. Now, let's find our du over dx. Our du over dx is 0 minus 6. So basically, our du over dx is just negative 6. So putting that here in our numerator, the du over dx, all over 2, and then the square root of u. And our u is again 5 minus 6x. Now, we can still cancel this one. So we have negative 3 all over square root of 5 minus 6x. So this is now our final answer. Okay, so we have another example. Y is equivalent to 4 over square root of 5x plus 3. So actually, there's many ways in solving this one. First way is taking this as our u and applying the quotient rule. So u and v. So and remember again, the derivative of a quotient is v du minus u dv all over v squared. So let's try to do that one. Copy the v, which is square root of 5x plus 3. Derive the u, which is 0 because it's a constant. And then copy the u, which is 4, and derive the v. In order for us to derive the v, our v is square root of 5x plus 3. In exponential form, that is 5x plus 3 raised to 1 half, right? So that is raised to 1 half. So basically, the derivative of this is putting the 1 half or the exponent beside our variable. So we have 5x plus 3, and then 1 half minus 1, we have negative 1 half, right? So that is negative 1/2. And then the derivative of our u. So in this case, the derivative of this is 5. So basically, we have 5/2 of 5x plus 3 raised to negative 1/2. So this is now our dv over dx. So let's just multiply that here. So we have 5/2 of 5x plus 3 raised to negative 1/2. And then our v squared. So our v is square root of 5x plus 3, and that is squared. So practically, you can cancel the square root and the squared in the denominator. So this one as well will be zeroed because that is multiplied to 0. So what we have now is negative 4 multiplied by 5/2, that is equivalent to 10. Because this will be cancelled, this will become 2. 2 times 5, that is 10. So we have negative 10 times 5x plus 3 raised to negative 1/2 all over 5x plus 3. And as you can see, this is negative, meaning to say we can put that down, and that will be equivalent to negative 10 all over 5x plus 3 and square root of 5x plus 3. Since again, 1/2, this will become 1/2, positive 1/2, and 1/2 is just equivalent to square root. So we have that. Or you can also write that in exponential form. We have negative 10 over 5x plus 3 raised to 3/2. Because this is understood as that has an exponent of 1, and this is understood to have 1/2. Now 1 plus 1/2, that is 3/2. So we have this as our final answer. And another easiest way to solve this problem is using the rule that we have discussed earlier. So if you can remember, we have the rule u raised to n, right? And for this one, the derivative of this is negate the exponent, copy the u or copy the equation, and then add 1 to our exponent. So multiply, and again multiply that to the derivative of u. So let's try to do this one. So since 4 over square root of 5x plus 3 is just basically equivalent to 4 over 5x plus 3 raised to 1/2. So as you can see, n here can be 1/2. So in deriving this one, our y prime now is 4 multiplied by the negate of the exponent, which is negative 1/2. And then copy our function, which is 5x plus 3. And then add 1 to the exponent. So 1/2 plus 1. So, and multiply that with the derivative of our u. So since the derivative of our u is 5, so we can just multiply that by 5. Now 4 times negative 1/2, that is negative 2, multiplied by the 5 here. So we have 5. And then we have 5x plus 3 raised to 3/2. So as you can see, basically this is just equivalent to 5x plus 3 raised to 3/2. As you can see from here, we have the same answer. So either way, either what rules are you going to apply, you will still have the same answer. This one. Okay, next example we have here. Y is equivalent to 3x plus 1 all over square root of 3x squared plus 2. So for this one, we can use the quotient rule for this one. So we can have this numerator as our u and the denominator as our v. So again, we have v du minus u dv all over v squared. So copying the v, which is y prime now, copying the v is square root of 3x squared plus 2. Then the derivative of our u is 3 minus copying the u, which is 3x plus 1. And the derivative of our v. Again, the derivative of our v is taking this one as exponent. So we have 3x squared plus 2 raised to 1 half. So our derivative now is 1 half times 3x squared plus 2. 1 half minus 1, that is negative 1 half, times the derivative of our u. So we have 6x. So basically, the derivative of v is equivalent to 3x times 3x squared plus 2 raised to negative 1 half. So this is now the derivative of our v. So multiplying that here, we have 3x times 3x squared plus 2 raised to negative 1 half. And then we have to divide by the square root of our v. So square root of our v, 3x squared plus 2 squared. So cancel the square root, cancel the squared. So we now have 3 square root of 3x squared plus 2 minus this one. We can multiply that here, the 3x only, because this term we cannot multiply this to 3x plus 1 because it has an exponent. You can only multiply terms with the same exponent. So 3x has an understood exponent of 1 as well as 3x plus 1. So 3x times 3x, that is 9x squared. Negative 1 times 3x, that is, let's just put this one inside the parenthesis so you won't be confused with the sign. So we have plus 3x. And then we have the 3x squared plus 2 raised to negative 1 half. And then the denominator is 3x squared plus 2. Now, simplifying this one, as you can see, this term can be separated and this term as well. Right? So let's try to simplify our final answer for this one. So probably we can have 3 over 3x squared plus 2 all over 3x squared plus 2. And this one we can have 9x squared plus 3x. And we also have the 3x squared plus 2 raised to negative 1 half all over 3x squared plus 2. So as you can see, this is understood to have an exponent of 1, and this one has an understood exponent of 1 half. Now, in simplifying a fraction with the same base, 1 minus 1 half, this one is equivalent to 1 half. Meaning to say, we can cancel this one here, and we can cancel half of this one. So what we have left now is 3 over square root of 3x squared plus 2. Because again, 1 minus 1 half from the numerator, that is basically equivalent to, cancel the 1 half here and cancel, this is again 1 half. So you can cancel the 1 half here. So what we have left is 1 half. So 1 half is just equivalent to square root. So we can put it this way. And for this one, we can also cancel this, or we can put this below because this is negative. So we can rewrite that as 9x squared plus 3x all over 3x squared plus 2, that is raised to 1, right? And then the other one is square root of 3x squared, or let's just put that in exponential form, 3x squared plus 2 raised to 1 half, positive 1 half because we put it in the denominator. So now, simplifying this, we have 3 over square root of 3x squared plus 2 minus, there's common terms in our numerator. So we can factor the common terms, which is 3x. 3x plus 1. And then for the denominator, we have 1 plus 1 half, so that is 3x squared plus 2 raised to 3 halves. So this is now our final answer. I hope you learned something from this video. These are all the discussion for this video, and I'll see you on the next videos. Thank you.